Hey you guys, let's finish this study guide. So we stopped on this problem right here, so let's get back to it. So this is a triangle, and we still have that right angle symbol. So I know that that's a right angle, which is 90 degrees. So that means whatever angles are next to it have to be complementary. They have to add up to 90 degrees. So let's go and set up an equation. I'm going to write whatever I have here, 5x minus 2, exactly as it's written. And I'm going to add it to whatever I have over here, plus 67. And I'm going to set it equal to 90 degrees. So let's go and solve this. I'm going to go and combine like terms. I have minus 2 right here, like negative 2, 67. Negative 2 combined with 67, that gives me 65. Bring down everything else. I have my equal 90, and I have my 5x. And because that 65 was positive, I'll have a plus sign. So now let's go and solve this. I'll subtract 65 on both sides. Subtract 65. 5x is equal to 90 minus 65, that's 25. Then I'll divide both sides by 5. X is equal to 25 divided by 5, that's 5. So x is equal to 5. Now let's go and find the angle measurements. One of them is already given to you. It says 67 degrees. So now let's go and find the other one. Every time I see an x, I'm going to go and substitute it in with a 5. So 5 times 5 minus 2. That's 5 times 5 is 25 minus 2. That's 23. So now I can double check my work by making sure my angle measurements add up to 90. 67 plus 23. Yep, that adds up to 90, so I know I did it right. Let's look at the next one. Now, these are vertical angles. That's because they're right across from each other. And I already know that vertical angles are supposed to be congruent. That means they're equal to each other. So watch how we're going to set up this equation. Whatever is written here, 7x plus 10, I'm going to write it down here because I'm going to set up an equation. Instead of adding whatever is written here, we're not going to do that. And we're also not going to set this equal to 90 degrees or 180 degrees. That's because this angle, this 7x plus 10 angle, is equal to this angle. So watch how we're going to do this. We're not going to set it to 90 or 180. We're going to set these two angles equal to each other. So 7x plus 10 on this side, 9x minus 22 on this side. Now, we didn't do a problem like this in class. This is actually more stuff that you'll see in 8th grade, but it's great experience just to get a little practice with this kind of stuff. So we need x on the one side of the equation. Right now, there's an x here and an x here. We want to combine those. So you can either do one of two things. You could subtract 7x on both sides, and that'll cancel it out here. Or you could subtract 9x on both sides, and that'll cancel it out here. Either way is fine. You get the same answer regardless, okay? We'll do minus 7x on both sides. So now that cancels out to 0. I'll subtract 7x over here. I'm left with 10 equals 9x minus 7x. That's just 2x. And then minus 22. So all I did was subtract 7x on both sides so that I could get the x's on the same side of the equation. So now this is just a two-step equation we've done for a long time. I'll eliminate the constant by adding 22 to both sides. And I'm left with 32 equals 2x. So now I'll divide both sides by 2 to isolate that variable. And x is equal to 32 divided by 2, that's 16. So x is equal to 16. So now everywhere I see an x, I'm going to go and substitute 16. So 7 times 16 plus 10. That's a parentheses. And I use the parentheses to remind me to multiply. 7 times 16 plus 10. That gives us 122. 122 degrees. Then down here, 9 times 16 minus 22. 9 times 16 minus 22. And that gives me 122. Hey, they're the exact same angle. And because they're vertical, that's what we want. This is 122 degrees. This should be 122 degrees as well. So I know I did it correctly. 122 degrees and 122 degrees. That is a hard problem, and you'll see more stuff like that in 8th grade, but it's always good to have that kind of practice here to challenge you, okay? Let's look at the next one. I'll give that an erase, and we'll scroll down. This one says, please identify the angle type and determine the measurement of the angle. So these are protractors. That's how we measure angles. So let's look at this first one. Here's my angle. It's clearly larger than 90 degrees, so I know that this is an obtuse angle. It's larger than 90. It's obtuse. So let's look at the angle measurement. We're going to look and see where it crosses the protractor here. All right, so let's look and see where it crosses. Looks like it crosses in between this 80 and that 90 mark on this lower ring. But it also looks on the outer ring like it crosses between 100 and 90. Because we have an obtuse angle, we want to choose the number between 100 and 90. And it looks like it's a little closer to 100, so it looks like that's 96 degrees. If you looked on this lower range of numbers, because when we look at a protractor, we have 0 all the way to 180 on the inside. And then we also have 0 all the way to 180 going in the other direction on the outside. You have to determine which angle measurement makes the most sense, okay? If I chose the 80 to 90, I would choose something like 83 degrees. It looks like that's where it crosses this 80 mark, between 80 and 90. That can't be right because it's an obtuse angle, and obtuse angles are greater than 90. So I'm going to choose the 96 degrees. Choose the angle measurement that makes the most sense based on how the angle looks. Looking at this one, let's look and see where it crosses. This is clearly an obtuse angle. It's almost a full straight angle. It's almost a straight line, 180 degrees. So this is going to be a very large angle. Let's look and see where it crosses here. Let's see, it crosses in between 0 and 10 on that lower range, but that can't be right. This is an obtuse angle. That's a large angle. So it must be in between this 180 and that 170, and it looks like it crosses somewhere around 172. All right, we usually take a range when we're dealing with protractors, right? If you chose 171 or 174, that'd be okay too. It's kind of hard to see exactly where it is on that one. Looking over here, this is clearly an acute angle. It's less than 90 degrees. So let's go and see how the angle measurement is. It crosses in between this lower range, between 50 and 60. That's like 55 degrees. And it crosses this outer range between 130 and 120. That's like 125 degrees. I need to choose the acute angle, which is this one, 55. 125, that's an obtuse angle measurement, and that can't be right. Choose the angle that makes the most sense. Let's look at the next one. Please find the area and the circumference of the circles below. Must include the units and your answer. Let's put the formulas up. The circumference is equal to pi times the diameter. The area is equal to pi times the radius squared. So let's go and look through this. The area is pi times r squared. So for this one, we would have 3.14 for pi. Let's multiply it by the radius squared. Now, this long line from end to end of the circle is 8 centimeters. That's the diameter. The diameter goes from one end of the circle to the other. The radius is what we need, and the radius is half of the diameter. If diameter is 8, the radius is just 4. So we're going to do 3.14 times 4 because that's the radius squared. Let's plug that in our calculator. 3.14 times 4 squared, and that gives me 50.24 centimeters squared. Because we had that squared, our units are going to have a square in them as well. Look at the circumference. That's pi times the diameter. So that's 3.14 times the diameter, which is 8 in this circle. So 3.14 times 8 gives us 25.12 centimeters. That's a decimal right there. There we go. Let's look at the next one. The radius here is 6 feet because the radius goes from the center of the circle to the edge of the circle. So here's our formula. Pi r squared, we would have 3.14 times the radius, which is 6 squared. Let's put that in our calculator. 3.14 times 6 squared equals 113.04 feet is the units here, squared. The circumference is pi times the diameter. So we have 3.14 times the diameter. The diameter is double the radius. If the radius here is 6, the diameter is going to be 12. It's just double. So 3.14 times 12 gives us 37.68 feet. Looking over here at this next one, we have the diameter is 12 centimeters because it goes all the way across the circle and through the center. So area is pi r squared. That would be 3.14 times the radius. The radius is half of the diameter, so the radius here is 6 squared. These are parentheses to remind me to multiply. Oh, it looks like we did that same thing over here. 3.14 times 6 squared, and we get 113.04. I meant to make those numbers a little different, so that's my bad. 113.04 feet squared for the area. But still, it's good practice. The circumference is pi times diameter. It'd be 3.14 times 12. And look, we just did that on the previous problem. Isn't that amazing? If the diameter is 12 here, the radius is 6 here, these are actually the same exact circle. We just labeled them differently with the radius and the diameter in one or the other. The circumference would be 37.68 feet. There we go. Let's give that an erase and let's scroll down. All right, these last few. So this one says, Emma says that if you're given the circumference of a circle, you have enough information to find the area of the circle. Is she correct? Explain why or why not. So we know that circumference is pi times the diameter. If we are given the circumference of a circle, let's say it's 31.4 is the circumference of a circle. We could go solve for the diameter, 3.14 for pi times the diameter. I could divide both by 3.14, divide by 3.14, and the diameter is just 10. So now I know the diameter is 10. That means the radius is half of that, which would be 5. And then area is pi r squared. So area is 3.14 times the radius squared. That'd be 3.14 times 5 squared. That'd be 78.5 for the area. So the answer is yes, you absolutely can find the area of a circle if you're given the circumference. That's because you can find the diameter if you're given the circumference. And then you can find the radius, and then you can use that to find the area. So absolutely, yes, you can. All right, let's look at these last two. All right. This one says, please find the area of the shaded region. Hint, find the area of the square, then the area of the circle, and then subtract. So let's look at this one. The area of the square. Area for a square is just side squared. Or when it's a rectangle, it might make a little more sense. Length times width. All right. So let's take 8 times 8. It's 64. That's the area of the square. Now let's go and find the area of the circle. We know it's pi r squared. So if we had that, we need to know the radius. That'd be the diameter. And what's great is that diameter is equal to this measurement, this length, which is 8. The diameter is 8, which means the radius is 4. So area is 3.14 times the radius 4 squared. So the area of the circle would be 3.14 times 4 squared gives me 50.24. So now, oh my gosh, what is going on? There we go. All right, so the area is 50.24 for the circle. Now, I just want to know the area of the shaded region, like these 4 corners over here. How much is that? So it's kind of like we had a square, right? This gray square, which was 64 feet squared for the area. And then we put like this white circle right on top of it. And we found that area to be 50.24. I'm going to subtract these areas, 64 minus 50.24. And once I do that, it's kind of like I got rid of all the area of the circle and I'm only left with what is left in that gray square. So 64 minus 50.24. That gives me 13.76 feet squared. That is the shaded region, all right? Now we have one more problem to go. I'm running out of time, so I'm going to do this in one more part. I'm also going to do some more word problems that we did today in class, just so you guys can see those again. I will see y'all in the next part.